Right now, astronomers are scrambling to verify a detection from the Atlas interstellar candidate that nobody expected and everyone's trying to explain. In the last 72 hours, three independent observatories have recorded periodic radio emissions from the object that don't match any known natural phenomenon in our databases, and the pattern is getting stronger as it approaches the sun. This isn't speculation anymore, but confirmed observations that have triggered emergency telescope time at facilities across four continents. Because if these signals are what they appear to be, we're about to witness something that could fundamentally change our understanding of interstellar visitors or force us to confront possibilities most scientists haven't seriously considered until now. What you're about to learn will separate the confirmed detections from the wild speculation flooding social media right now. I'll show you exactly what multiple teams have measured, why the signal's mathematical structure has researchers double-checking their equipment, and what British physicist Brian Cox meant when he posted that science must follow the data wherever it leads, even when it leads somewhere uncomfortable. Everything I'm sharing comes from official sources, including urgent circulars from the International Astronomical Union, raw data from the Very Large Array, spectroscopic observations from Keck and Gemini, and real-time tracking from solar observatories that are watching this object's every move as it races toward tomorrow's perihelion. Here's what's confirmed as of this morning. The Parkes Radio Telescope in Australia first detected structured emissions at 1.42 gigahertz on January 11th at 0347 Universal Time. The signal repeats every 4.7 hours with a consistency that rules out random noise or equipment malfunction. Within 6 hours, the Green Bank Telescope in West Virginia confirmed the detection, recording the same periodicity but noting frequency drift consistent with an accelerating source. The Arecibo successor at the Fast Radio Telescope in China picked up harmonics at twice and three times the base frequency, which suggests a complex emission mechanism rather than simple thermal radiation. Most significantly, the signal strength increases measurably with each rotation period, as if something is warming up or activating as solar radiation intensifies. The signal itself defies easy explanation. What's confirmed is that it consists of narrow-band pulses lasting 17 milliseconds each, separated by intervals that follow a mathematical progression. The progression isn't random, but follows a pattern where each interval equals the previous one multiplied by 1.618, which any mathematician recognizes as approaching the golden ratio. Natural pulsars emit regularly but not in progressive patterns. Natural masers, those cosmic microwave lasers, emit narrowband signals, but not in structured sequences. The polarization is circular rather than linear, rotating through the full 360 degrees in sync with the emission pattern. Signal strength has increased 30% in the last 48 hours alone. What changed everything was yesterday's discovery that the radio emissions correlate with optical brightening. The object flashes in visual light exactly 2.3 seconds before each radio pulse begins. This offset remains constant despite the object's changing distance and velocity. The visual flashes are extremely brief, lasting less than a tenth of a second, but they've been captured by high-speed photometry at 3 observatories. The spectrum of these flashes shows emission lines that don't match any known cometary species. Instead, they resemble certain rare Earth elements undergoing stimulated emission, like a natural laser, but the energy required would be enormous. Brian Cox addressed the situation on a hastily arranged podcast yesterday, emphasizing that extraordinary observations demand extraordinary scrutiny before reaching extraordinary conclusions. Cox pointed out that we've been surprised by natural phenomena before, citing pulsars that were initially labeled LGM for little green men before we understood them as rotating neutron stars. He stressed that the scientific method requires us to exhaust natural explanations before considering artificial ones, but also acknowledged that the data pattern is unlike anything in 50 years of radio astronomy. His key point was that we must let evidence guide us rather than forcing observations to fit our preconceptions. The geometry makes this even more peculiar. The object approaches from 67 degrees above the ecliptic plane, meaning it spent most of its journey invisible from Earth-based surveys. The radio emissions are highly directional, detectable only when the object's rotation brings the source toward Earth. This beaming explains why we didn't detect signals earlier and why they cut out abruptly every 4.7 hours. But here's what doesn't make sense naturally. The beam width is extraordinarily narrow, less than 2 degrees, requiring a emission mechanism more focused than any known cometary process. It's as if the object has a searchlight that sweeps across space, and Earth happens to be in its path. Let me be absolutely clear about what we don't know. We don't know if these signals are artificial. We don't know what physical mechanism could produce such structured emissions naturally. We don't know why the pattern follows mathematical constants. We don't know if the correlation between optical and radio emissions is causal or coincidental. We don't know if the object will survive tomorrow's perihelion passage at zero point 0.8 astronomical units from the Sun. What we do know is that multiple independent teams have verified these observations. The data are publicly available for anyone to analyze, and the next 72 hours will either deepen the mystery or resolve it completely. The numbers tell an incredible story. At the current signal strength of 23 Janskis, the object is emitting about 10 to the 15th watts of radio power. That's roughly equivalent to 1 million typical FM radio transmitters operating simultaneously. For a natural object estimated at only a few kilometers across, generating this much focused radio emission requires energy densities that push the boundaries of known physics. The energy has to come from somewhere. Solar heating alone can't account for it. Chemical reactions fall short by orders of magnitude. Nuclear processes would require isotope ratios we're not seeing in the spectra. 4 competing natural explanations are being tested right now. First hypothesis suggests the object contains exotic ices that undergo phase transitions when heated, creating natural matter emissions. The problem is that no known ice produces emissions at exactly 1.42 gigahertz with these characteristics. Second hypothesis proposes that solar-wind interaction with an unusually strong magnetic field generates synchrotron radiation. But the required field strength would be 10,000 times stronger than any comet we've measured. Third hypothesis involves piezoelectric effects in crystalline structures compressed by thermal stress. This might explain the periodicity, but not the progressive mathematical pattern. Fourth hypothesis suggests we're seeing a completely new phenomenon related to interstellar chemistry we don't understand yet. The speculation file has grown considerably, and I'll separate confirmed observations from theoretical possibilities. What's confirmed is that signal complexity has increased each day we've observed it. Early detections showed simple pulses. Now we're seeing modulation within each pulse that could represent information encoding or could be natural interference patterns. What some researchers privately discuss is whether this modulation follows compression algorithms similar to those we use for data transmission. What's confirmed is that no terrestrial or satellite interference can explain the signals, as verified by correlation between widely separated observatories. What a few brave scientists wonder is whether we're witnessing a probe activated by solar energy, though saying this publicly risks careers without more evidence. Here's where the story gets stranger. In the last 24 hours, 2 other phenomena have emerged. The object's acceleration curve changed again, showing thrust vectors that don't align with the sun's direction. If this is outgassing, the vents must be oriented in a configuration that defies random probability. The object also began shedding what appear to be metallic particles based on radar returns. These particles maintain formation rather than dispersing randomly, traveling alongside the main body like a convoy. Natural explanations exist for both observations, involving magnetic field interactions and electrostatically charged dust. But the combination of all these anomalies in one object strains coincidence. The timeline for the next 3 days is critical. Tomorrow at 1400 Universal Time, the object reaches perihelion, passing behind the sun from Earth's perspective. For 16 hours, ground-based radio telescopes lose contact. Only spacecraft near the sun can monitor what happens during this crucial passage. The Solar and Heliospheric Observatory will watch for visual changes. Parker's solar probe, if positioned correctly, might detect particles or fields. The European Space Agency's solar orbiter could capture spectroscopic data from a different angle. But none of these spacecraft were designed to track fast-moving objects or decode complex radio signals. If the signals are natural phenomena triggered by solar heating, they should peak during perihelion, then gradually decay as the object recedes. If they're artificial, we might see deliberate changes in the pattern, perhaps acknowledgement of our observations or adjustment to maintain contact as geometry changes. If the object fragments under solar stress, the signals would cease abruptly. Each outcome tells us something profound about what we're dealing with. The universe is about to grade our homework on this mystery. Professional astronomers are taking unprecedented steps. The International Astronomical Union called an emergency session for the first time since 2017's Oumuamua discovery. The SETI Institute has activated all available resources while emphasizing they're looking for natural explanations first. Radio observatories worldwide have cleared their schedules to maintain continuous coverage. Even military tracking stations have been quietly asked to monitor the object, though official statements remain classified. This level of coordination hasn't happened since we thought we'd found phosphine in Venus's atmosphere. The math behind the signal pattern deserves attention. The golden ratio appearing in timing intervals could be coincidence, but it shows up in many natural systems from spiral galaxies to plant growth. What makes this detection unusual is the precision. Natural systems approximate mathematical constants. This signal matches them to 6 decimal places. The frequency drift follows a quadratic equation that perfectly matches the object's calculated acceleration. The polarization rotation rate equals the emission period divided by pi. Either nature is showing us mathematical relationships we've never seen before, or something is deliberately encoding mathematical constants we'd recognize. Public reaction has been extraordinary. Social media erupted with everything from scientific analysis to conspiracy theories. Amateur radio operators have aimed their equipment skyward, though most lack the sensitivity to detect the signals. Universities report surge in astronomy course enrollments. Religious groups debate theological implications. Stock markets showed brief volatility before stabilizing. Governments have said little officially, but increased activity at space tracking facilities hasn't gone unnoticed. Humanity is watching, waiting, and wondering if everything is about to change. What Brian Cox emphasized in his latest statement is worth repeating. Science has surprised us before. Pulsars seemed artificial until we understood them. Fast radio bursts mystified us until we traced them to magnetars. The wow signal remains unexplained but probably natural. Each mystery eventually yields to careful investigation and rational explanation. But Cox also noted that dismissing observations because they're uncomfortable is just as unscientific as accepting them without evidence. The data will tell us what this is if we're brave enough to listen without prejudice. Let's talk about what would constitute proof of artificial origin versus natural phenomenon. Artificial signals would show deliberate information encoding, respond to our transmissions, or demonstrate technology beyond our current capabilities. Natural phenomena would follow physical laws even if we don't understand them yet, correlate with thermal or chemical processes, and eventually repeat in other similar objects. Right now, we're in the ambiguous middle where the signals show structure that could be either. The next 72 hours should push us firmly toward one conclusion or the other. The comparison with previous interstellar visitors matters here. Oumuamua showed acceleration we couldn't explain until hydrogen ice models provided a solution. It tumbled chaotically rather than rotating smoothly. No radio emissions were detected despite extensive monitoring. Borisov looked and acted like a normal comet except for its hyperbolic trajectory and carbon monoxide abundance. Neither showed anything like these structured radio signals. If this object gets designated 3I Atlas, it would be the first interstellar visitor with active emissions beyond typical cometary activity. Several research teams have published preliminary papers on preprint servers, rushing to document their observations before peer review. One team calculates the energy requirements for the observed emissions and concludes an internal power source is necessary. Another team argues that interaction between interstellar medium and solar wind could generate the required energy through magnetic reconnection. A third paper presents statistical analysis showing the signal pattern has less than 1 in a million probability of arising randomly. These papers will face intense scrutiny, but they represent science working in real time, transparently, under extraordinary circumstances. The instruments watching this object represent humanity's best technology. The Very Large Array combines 27 radio dishes to achieve resolution equivalent to a telescope 36 kilometers across. The Atacama Large Millimeter Array uses 66 antennas to detect molecular emissions invisible to optical telescopes. Optical observatories employ adaptive optics to cancel atmospheric distortion, achieving nearly space telescope clarity from the ground. Spacecraft around the sun carry instruments designed to study our star, but now turn toward this visitor. We're throwing everything we have at this mystery. For context, consider what discovering artificial signals would mean. It wouldn't necessarily imply aliens are visiting. A probe could be ancient, its creators long extinct. It might be a beacon rather than a vehicle. It could be debris from some cosmic engineering project, or it might be technology so advanced we can't recognize its purpose. Carl Sagan once said that any sufficiently advanced technology would be indistinguishable from magic. We might be seeing something that makes perfect sense to its creators, but seems impossible to us. But let's ground ourselves in what's most likely. Natural phenomena we don't understand yet have surprised us throughout history. Saturn's hexagonal pole, sprites and jets above thunderstorms, ball lightning, earthquake lights, each seemed impossible until we understood the physics. This object might be showing us a new phenomenon related to how interstellar material interacts with stellar radiation. The mathematical patterns might emerge from feedback loops we haven't modeled. The radio emissions might be natural masers pumped by conditions we've never observed. Nature has more imagination than we do. The next critical observation window opens in approximately 30 hours when the object emerges from solar conjunction. Southern Hemisphere radio telescopes are already positioned to reacquire the signal if it survived perihelion. The first priority is determining whether the emission pattern changed during the solar passage. Any deviation from the established pattern would provide crucial clues about the mechanism. If signals ceased entirely, we'd know the source couldn't withstand solar heating. If they strengthen, it suggests solar energy pumps the emission process. Here's something that hasn't been widely reported. 3 days ago, before the radio detections became public, an amateur astronomer in Japan captured something unusual. Their time-lapse images show the object's coma pulsing in brightness with the same 4.7-hour period later found in radio emissions. This independent confirmation from before anyone knew to look for periodicity strengthens the case that something real and unusual is happening. The amateur astronomy community has now mobilized globally, providing round-the-clock coverage that supplements professional observations. The possibility of fragmentation during perihelion raises additional questions. If the object breaks apart, would each fragment continue emitting signals? Would the mathematical pattern distribute across multiple sources or cease entirely? Some models suggest fragmentation might actually intensify emissions by exposing fresh surface area to solar radiation. Others predict complete cessation as the mechanism requires the object's full structure to function. We'll know soon enough. Scientists are preparing for every contingency. If signals strengthen post-perihelion, proposals are ready for immediate submission to every major observatory. If signals cease, teams will analyze final transmissions for clues about what failed. If the pattern changes dramatically, mathematicians and cryptographers stand ready to decode any potential message. If multiple fragments emerge, each with different emission characteristics, dynamicists will model how they separated. The scientific community hasn't been this coordinated since the first gravitational wave detection. The energy mystery deepens when you consider thermodynamics. The object has been in interstellar space for potentially millions of years at temperatures near absolute zero. Sudden heating to hundreds of degrees Kelvin should cause explosive outgassing, possibly shattering a fragile structure. Yet the signals remain stable, even strengthening gradually rather than showing chaotic variation. This controlled energy release suggests either an incredibly robust natural structure or something designed to withstand exactly these conditions. What would rewrite science isn't just finding artificial signals, but understanding natural processes that mimic them so precisely. If nature can create narrowband radio emitters that broadcast mathematical constants, What else might be out there that we've dismissed as noise? If interstellar chemistry produces effects that look technological, how do we distinguish actual technology? These questions matter whether this object is natural or artificial because they challenge our assumptions about what signatures to seek in our search for intelligence or just understanding the universe. The orbital dynamics provide one piece of good news. Even after perihelion, the object remains observable for several months as it climbs away from the sun. This extended visibility window means we can conduct thorough follow-up observations rather than rushing to conclusions. Every major telescope on Earth and in space will get a chance to study this visitor. The accumulated data should definitively answer whether we're seeing new physics or something else entirely. Media coverage has been remarkably responsible so far, with most outlets emphasizing the preliminary nature of observations and the need for verification. Science communicators have done excellent work explaining radio astronomy, the difference between correlation and causation, and why extraordinary claims require extraordinary evidence. The public seems genuinely interested in the scientific process, following updates with patience rather than demanding immediate answers. This might be humanity's most mature response to a potential discovery of this magnitude. The next data release comes in 12 hours, when Japanese and Australian radio telescopes publish their latest observations. These facilities have been tracking the object continuously, building a precise map of how the signals evolve. Any sudden changes in the last day before perihelion would indicate the sun's influence on the emission mechanism. Stability would suggest the process is internally driven rather than environmentally triggered. Either result narrows the range of possible explanations. Remember that we're watching this unfold in real time with no script and no predetermined outcome. The universe doesn't care about our expectations or hopes, it simply is what it is, and our job is to observe accurately and interpret honestly. Whether this object rewrites science or simply adds another chapter to our understanding of natural phenomena, we're privileged to witness the process of discovery as it happens. The 72-hour countdown that began when I started speaking is now down to 71 hours and counting. Each passing hour brings new observations that either deepen the mystery or point toward resolution. The object continues its inexorable plunge toward the sun, carrying its secrets with it. Our instruments stand ready to capture every photon, every radio wave, every particle this cosmic visitor emits. Whatever truth lies hidden in those signals will soon be revealed. 3 things could happen in the next 3 days that would genuinely rewrite science. First, the signals could encode information that proves artificial origin beyond doubt. Second, we could discover a natural process that generates these patterns, revolutionizing our understanding of astrophysics. Third, the object could do something completely unexpected that forces us to reconsider basic assumptions about interstellar visitors. Each possibility is profound in its own way. The human story here matters too. Thousands of scientists, engineers, and support staff are working around the clock to solve this mystery. Graduate students are pulling all-nighters to process data. Telescope operators are battling weather and equipment failures to maintain observations. Theorists are testing models against observations in real time. This represents humanity at its best, cooperating across borders and disciplines to understand something larger than ourselves. As we approach the critical perihelion passage, every observation becomes more precious. The object is accelerating, diving toward its closest approach to our star. Solar radiation intensifies with each passing hour. The signals continue their mathematical dance across the electromagnetic spectrum. And Earth watches with instruments that represent centuries of technological development pointed at a visitor that might change everything we thought we knew. Tomorrow brings perihelion and temporary loss of contact. The day after brings reacquisition and first assessment of what changed. 3 days from now, we'll have enough post-perihelion data to draw preliminary conclusions. The universe is about to teach us something profound, whether it's new physics, confirmation that we're not alone, or simply another beautiful example of nature's complexity exceeding our imagination. Whatever happens next, you're witnessing history being written. Stay tuned for our next update when this cosmic visitor emerges from behind the sun and shows us whether science textbooks need a new chapter.